Hello friends, welcome to the video lecture series on machine learning in Python and R. So till now we have seen about what is machine learning. We have seen couple of example and we tried to understand that what is the difference between current state of computing, current way of computing to how machine learning way of computing is different. In this tutorial we are going to see about what are the different types of machine learning. So before getting into actual formal definition, let's try to evolve the concept of types of machine learning. For that, let's try to understand three different examples and then we will classify those examples into different machine learning types category. Let's see first example. Let's say we have been given a temperature of particular city in New York for the whole year 2016. So for all 365 days, for each and every day we have been given a temperature of the New York City. So from the 1st January to 31st December. So total 365 records are available to us. Now let's define the problem. Now based on this data, our task is to find what is the temperature at 1st January 2017 in New York. So can we predict based on whatever the last 365 days data available with us about the New York City temperature in year 2016? Based on that, can we predict on this date what will be the temperature of the New York City? So let's try to define a very mathematical way this problem. So we have very much used to with this notation y is equal to f of x, where f is the modeling of data x and y. X is the independent variable and y is the dependent variable. So you can consider this part which you are going to predict in a 1st January 2017 New York City temperature, which you can consider as a dependent variable y, while x you can consider as a input variable, that whatever data has been given to you. So x will be nothing but your input data and y will be nothing but your output data. Now let's observe some of the points here. These two things has been given to you, x and a y. X will be somewhere around temperature and y will be somewhere x will be somewhere around date and y will be somewhere around temperature. So that is the input training data has been given to you. You model this function and you create f. Now once the new data has been given to you, that is a new date 1/1/2017, your job is to predict what will be the temperature of the New York City. That will become your testing set output. So input given temperature for the last 1 year in terms of date, output given the temperature, and if you have observed, output is a continuous real value here. So let's keep aside this problem and let's try to understand one more example. Let's say you have been given a lot of images of cat and dog. So our task is to find which one is cat and which one is dog. So let's define the same way this problem. Y is equal to f of x, where x is nothing but the input image has been given and y is nothing but particular image is cat and particular image is dog. Once we have already trained this model and we create this function f, we have been given unknown image cat or dog, and our task is to predict whether particular image contains cat or dog. So in this example, we have been given an image photo as an input. The output will be whose particular photo is dog or a cat, whose photo is this in terms of testing set output. And if you have observed here, in this case output will be discrete, binary, or kind of either dog or cat. It's not a continuous value, but it's a discrete value, it's a set of value. So compared to our earlier example, in this case we don't have a continuous value output, but we have a discrete set of output. But there is a common thing between first example and a second example is that in both the example we have been given an input and we have been given an output. Based on that we need to model this function f, and now once f has been trained we have been given a new testing data in form of x, and our task is to predict particular y. Y can be continuous in our earlier example, y can be discrete in this example. So we have seen the two example. Let's see, please bear with me, this is the last example and then we will classify those example into different machine learning category. Let's say we have been given same way all those images of cat and dog, but in this case we don't know what particular image is cat or particular image is dog, and our task is to group this animal into two category. So only input has been given, no output has been given, and our task is to model this f in a such a way that this cat and dog photo has been divided into two category, where first category or first cluster of image contains only cat photo and another cluster of image contains only dog photo. So that is the input. So image photo has been given as the input and output given no output. In this case we don't know whether particular image is cat or image is dog. So let's define a formal way these three example into three different category. So this is the broad way of classification of machine learning category. There is a machine learning has been divided into supervised learning and unsupervised learning. There is another category which is also getting very much hype in current days, which is a reinforcement learning. We are not going to discuss this reinforcement learning for time being. We'll divide this our whole concentration of course into supervised learning and unsupervised learning. And supervised learning again classified into regression and a classification. So let's divide all those three example what we have seen in earlier into regression, classification and unsupervised learning. So whatever the first example we have seen, that is a weather example. We need to predict the weather of the New York City for a given date. That is nothing but the regression problem. Then we will see the characteristic and what is the difference between regression and a classification, and what is the difference between supervised learning and unsupervised learning. Another example we have seen, we need to predict whether photo contains a dog and a cat. So that is the classification problem. You are trying to classify based on whatever image has been given to you, whether particular image is dog or a cat. And the last example we have seen, put this dog and cat photo into different group, into different cluster, so that one cluster contains only dog photo and another cluster contains only cat photo. So that is a third example we have been assigned to the unsupervised learning. So first example will be classified as a regression problem, that is nothing but the superset of the supervised learning. Second example will be a part of the classification machine learning algorithm, classification problem, that is the part of supervised learning. And the last example we have seen into clustering, that is nothing but the unsupervised learning. Now let's see the difference between the supervised learning and unsupervised learning. And once you have been classified, the problem is type of supervised learning, whether you can apply the regression or even a classification. So if you have seen in a supervised learning, the very first two example, in both the example we have been given input and output both, and our task is to model function f. Now once you know that particular example or particular data type or particular data, our training data, we have both input and outputs are available. Let's classify into two different in category, regression and classification, based on whatever the output has been given. So if you see this output is continuous in case of, because weather is always continuous, it can be any real number. So if it is a continuous value, it's a regression kind of problem. And if it is output is discrete, that is a set of value only possible in an output, then it's a classification problem. So if input and output both has been given, it's a supervised learning problem. And out of supervised learning problem, if you see the output, if output is continuous, it's a regression problem. If output is a discrete, it's a classification problem. So this is all about the story of the supervised learning, how it is different from the unsupervised learning. Now if you see unsupervised learning, we have not been given any kind of output. We don't know whether particular image is cat or particular image has a dog. We have been just given a bunch of image and our task is to group them into different cluster. So the major differences between supervised learning and unsupervised learning is input is given in both the cases, but output has been given only in a supervised learning. And in case of supervised learning, again we classify the problem into two categories, regression and classification, based on output. If output is continuous, it's a regression problem. We can apply all regression kind of algorithm, and in output is a discrete, we can classify into classification problem. So we are going to see lots of algorithm related to the regression problem, like linear regression, multiple regression, polynomial regression, support vector regression, decision tree regression, random forest regression. The same way all classification algorithm and unsupervised learning related clustering algorithm also we are going to see in this tutorial. So that's it for this lecture, friends. I hope you understand this video, and if you haven't understood anything, please write it into comment. And at last, thank you guys for the watching. If you haven't subscribed my channel, please do subscribe to support the channel.